So, without further ado, what am I covering in this talk? Well, firstly, I want to talk about how I see where I am with Polkadot basically right now, right? So it's kind of a snapshot of my thoughts. Now, many of you probably already know about Jam, project that I've been working on that is heavily connected with Polkadot, protocol that will ultimately, we hope, power the next phase of Polkadot. But I also want to talk a little about zero-knowledge crypto techniques, particularly with regards to scaling, what blockchains can do. And I want to talk also a bit about the tokenomics of DOT. And then, the next part of the talk, I want to talk a bit about some of the things that I've been working on, which I hope will improve or introduce new capabilities into, well, particularly into Polkadot, but generally into the world of Web3. And there's a few different parts to this. And some of them are more detailed than others, as you'll see. Okay. Right, let's kick off. So, Jam, where are we at? Basically, you know, it started off at 0.1, and it's getting to 1.0, at which point, at least as far as the Jam protocol is concerned, Polkadot will be ready it will be ready for Polkadot to upgrade to. It is stabilizing. There's an increasing focus on the optimization, what we call gas modeling. Gave a talk about this at the ETH Prague, like one of the Ethereum conferences earlier this year. And it's actually quite an interesting topic, gas modeling. I'm going to get onto it a little bit in a second. But it's a very tricky little thing to get right. Expect the audit for the protocol to begin this year. There's not all that much to do in the 0.7 series. The 0.8, which will introduce the gas modeling, there's probably a bit more to do, but I expect us to get to 0.9, at which point the audit will begin later this year, nonetheless. Having a core protocol is one thing. Being able to develop on it is a totally different thing. You need an SDK, you need docs, all this sort of thing. And this is in the early stage. Now, it's possible to develop software on Jam, and you know, at Parity, we are, well, to a large extent, I am, sort of trying to do this as best as possible, like build this SDK and publish it. But realistically, it's going to need more effort, more time over the coming months and years. Now, it doesn't just have to be Parity that builds the SDK, of course, that makes an SDK. Other teams can do this, and I do expect there to be others building their own SDKs for creating software on Jam. We're already starting the standards process for inter-service messaging, which is sort of Jam's, if you like, equivalent of XCM or XCMP, I suppose. And Core VM, which is something that I'm going to demo a bit later on, this is increasingly becoming part of the SDK, and this is going to increasingly be part of the SDK in the coming months. Core VM already supports, I mean, a lot of things: audio output, video output, data I/O, transaction-based processing is coming into service communications. One thing it's not supporting yet is EVM. But that is sort of something that we want to build in, and co-scheduling, or something I've called in the past core play, also something that we want to build in. This is going to come over the next 12 to 24 months, I expect. Jam governance. This is an interesting question that came up in one of the Jam chat rooms, I think in the last week. In essence, this is my attempt to try and make myself not a single point of failure for Jam, and try to reduce or increase the bus factor. Like at the moment, basically the grey paper or Jam's protocol evolution has a bus factor of me, and it would be nice if it didn't, both for Jam and me. So, we define jam as the contents of the grey paper, the jam technical specification. The latest grey paper is therefore the latest jam. And if a grey paper is audited, then that would imply it defines a jam that is production grade. Simple enough. How does the grey paper change in the future if it's not me who is deciding the changes? Well, basically, I will inaugurate a board of editors. This board of editors will be seated by those who actually are contributing to the grey paper that I think actually understand what's going on and are useful in creating useful contributions. I would expect these initial members to have a deep and excellent technical involvement in an implementation of jam. I don't intend to step down or anything. I will remain editor-in-chief. I just want to kind of reduce my workload as much as possible. And so give others the rights to basically help propose, review, and merge changes into the grey paper repository. And also, as jam sort of moves beyond version 1, the grey paper editorial board will be effectively those individuals who will be meeting, discussing, determining the direction that jam will evolve into, how it will prioritize one thing over another thing. And in essence, we'll look after that kind of strategic level rather than just looking after relatively minor changes or specific alterations. Inevitably, there will be opinion, and it's basically this editorial board that over time whose opinion should matter. I intend to announce a deputy who will take over in case I'm unavailable or on holiday or whatever, and devolve. And then ultimately, those deputies will have the duty of selecting, inviting, and deciding on other people into the editorial board. And hopefully we can get to a point where this thing can just, exist all by itself. Potentially involving external bodies, like, for example, the Polkadot Fellowship. I do intend to place the grey paper under an open license. I haven't decided which one yet, but probably going to be copyleft and probably going to have some affordances or protections against patents. Polkadot governance can, of course, choose what protocol it runs on. Polkadot is a sovereign protocol, and its governance can represent that sovereignty, or the decision-making apparatus of that sovereignty. And at the moment, the Polkadot governance has basically said it wants to use jam. Fine. Other networks could do the same. Jam is an open protocol. Now, if for whatever reason jam sort of evolve, we'd assume that Polkadot sort of stays up to date with jam. I mean, maybe it doesn't. Maybe it just fixes itself at a version and then sort of stops. But if it didn't like the direction, and if it did want to keep up to date, if it wanted to move in a different direction, it would also be able to sort of change the core protocol or even fork the grey paper if needed. This is all to say that sort of jam is its own thing, and it's, I'm hopeful that the two will have the same a mutually beneficial relationship for a long time to come yet. But if for whatever reason they don't, there is a means of allowing Polkadot and jam to sort of do their own thing. Now, if as long as they are aligned, then I would expect Polkadot governance to contribute materially to the maintenance of the grey paper editorial board, and if other protocols use jam, I would expect the same. All right, so that's jam as it stands, or jam as as it imminently will stand. ZK, I want to get onto ZK now. I get asked about this quite a bit. Ethereum is very keen on ZK. Most of their roadmap is sort of very ZK oriented, and it's while jam doesn't really use ZK beyond its very particular block building kind of consensus mechanism, it is an important consideration. Like, at what point will ZK become a viable, commercially viable means of scaling compute? Is it already there? How long if it's not there, how long do we think it will take to get there? Now, if you look at some of the materials in the Ethereum ecosystem, you're going to find, in particular, this like ethprovers.com. You'll find some very surprising numbers out there suggesting that it's already economically viable. It's not. We've actually done some digging, and we found that these numbers are basically lies. But it's not that far off. It's not as far off as it was, in particular, 18 months ago. So let's look at some of the numbers. 34%. Now, this is basically how the time it takes, or the amount slower that PVM is, our virtual machine that executes all of the jam code, basically our version of the EVM in some sense. This is the amount slower compared to native. So basically, if it took 34 minutes on native, it would take 100 minutes on jam, on PVM, I should say. Now, this is pretty good. We're pretty happy with this. Probably get this bigger. In some things, it's more like 50%, sometimes even more than that. But this is specifically SHA-1 hashing, and I guess SHA-1 hashing is maybe a little bit slower under PVM. Maybe it's when you're compiling natively, maybe there's some, I don't know, SIMD that you can do or something. Some optimizations, probably. This is the amount of times more expensive to prove that execution trace using the best prover that we could find, which is Succinct's SP1, compared to just executing it on PVM, right? So it's not compared to native, it's compared to PVM, which is already like 34% slower than native. And this is as of right now. We use the latest versions. It also assumes that we're using a single GPU, because that's what the public code base allows. Like if you use the closed source thing, then you can maybe scale it out over a GPU cluster, but the public code base assumes that you just got one GPU. Also using SHA-1 hashing, so it's exactly the same compute as we were doing here. Now, when we tried this out 18 months ago, this was quite a lot bigger. This was, I think, around 60 million, 64 million, something like that. And so the costs actually come down quite a lot. Why? Well, probably GPUs are a bit cheaper to rent out these days. But also, there's probably an order of magnitude, maybe a bit more, that have been improved, that is improvement in the software, right? Now, it's worth saying we didn't use SP1 18 months ago. We used a different one, RISC-0, the RISC-0 machine. But nonetheless, it's clear the state of the art is improving, and by a fairly substantial amount. Still, this is quite a big number. This is quite a big slowdown. Now, we come on to this gas metering. So it's all very well executing some code fast, but what if you can't trust the code? Then you have a problem, because then someone can make code that explicitly executes slowly, and if your consensus relies on basically coming to a decision in a particular period of time, you're kind of screwed. You're at the mercy of malicious people who put coding to your system. Now, this isn't so much of an issue with Polkadot, because we had like parachain slot auctions, so we kind of knew the people that were putting code into the system probably weren't going to try and take down Polkadot. However, if you're trying to do anything more general, then it can become an issue. So, how do we manage this? Well, basically, we come up with estimation mechanisms for how long it's going to actually execute for. Effectively, worst case, right? So it's like, given this program and this input, how long is it going to run for? And we can effectively give a worst case, right? Now, the degree to it, and we will assume that it will never possibly run slower than this worst case, because if it is, it's insecure. If we can make it run 10 times slower than our estimation, that's a big problem. So how bad is our worst case estimation, our secure worst case estimation? Turns out that, at least for SHA-1 hashing, it's 4.5x, right? Which basically means it's going to run 4.5 times slower if we can be certain that no attacker could put, malicious code or malicious inputs to make it run even slower than that. And this is the level of security that we need if we're going to execute all this stuff in consensus under time constraints, or where the consensus mechanism requires us to have time constraints. Now, we expect this to decrease, which is to say get more efficient. This is this is the best we could do so far after a week or two of trying. It's likely that this multiplier is going to go down. It's probably not going to go down that much more in general, though. Maybe, I don't know, to pick a number out of the air, 3x is a good target. Now, for Polkadot and for Jam, we use a protocol called ELVS, which gives us security. Basically allows us to be sure that some particular piece of computation was done correctly. This is the same thing, in essence, that the ZK mechanisms are doing, right? ZK provides a specific proof. ELVS, more like it's a crypto-economic game, and the proof is in some sense the sort of signatures of the participants of the game, along with a bunch of assumptions that, for example, the participants are no more than a third of the participants are malicious. Now, in order to run ELVS, you basically have to re-execute work, and the participants randomly select themselves as to whether they're going to re-execute or not. But basically, work is re-executed about 33 times, right? So basically, the cost is 33 times what it would be to run regularly under this secure metering model, which means we can work out exactly how much more expensive for baseline hardware costs ZK is over ELVS. And it turns out it's about 4,000, right? So it's basically 4,000 times more costly to prove things correct using ZK as opposed to sort of prove things correct using our crypto economic system, ELVS. If you want, this is kind of like comparing roll-up mechanisms. 4,000 times is quite a lot more costly. It's going to have to come down quite a lot in cost before, it makes sense, right? And it turns out that we can sort of improve ELVS quite a bit yet. However, hardware costs are not the whole story. Let's think about this a little bit. Firstly, sysadmins cost the same regardless of what hardware they're running, right? And it turns out that actually sysadmins are probably going to be the greater cost than hardware. So that aspect is kind of constant. Furthermore, to manufacture security, we need to be confident that no more than a third of the participants are bad, which basically means we're going to have to do some sort of filtering. Generally, for Polkadot anyway, we use staking as our filtering mechanism with a threat of slashing, so it's kind of risk capital. And by having risk capital, we filter participants, validator operators essentially, from the good ones, or the probably good ones, from the probably bad ones. Unfortunately, staking costs a lot. I'm going to look into that in a few seconds. But anyway, the point is that this isn't just about hardware costs. It's not even just about sysadmin costs. It's also about staking costs. Now, ZK doesn't have that issue per se, right? If there was a proof that was created for the ZK mechanism, it's either correct or it's not correct, and you can pretty much tell. Now, a single GPU is slow, right? So if you use a GPU to produce one of these proofs, it's going to take ages, right? It's like, I don't know, an hour plus, right? Hours. When it costs, when it takes, milliseconds or a few seconds on just PVM, right? On a kind of regular CPU core. So this isn't so good, but it turns out that it's been demonstrated that you can parallelize this stuff. So if you have enough GPUs all sort of connected together in a cluster, you can reduce the latency. Now, the degree to which you increase the cost, which is essentially the overhead or the efficiency coefficient, is uncertain. It's uncertain because the guys that have done this haven't told us. They don't want to tell us, I don't think. So basically, we're going to have to either try to somehow scheme an experiment where we kind of measure this stuff surreptitiously, or code it ourselves, or maybe there's some literature somewhere that we haven't found yet. Now, in addition to this rather substantial problem, there's also the issue of verification and settlement, which at the moment, if you do it, for example, on Ethereum L1, actually costs more than producing the proof itself. We calculated it's about maybe $1.20 to produce a proof, which I'm coming to in a second. It's actually like $1.25 or something to check that on Ethereum L1. Now, of course, if you have your own chain, you can you can probably get this cost down a lot. But still, somehow you're going to have something that is doing verification, settle, or settlement, finality, and storage. You still need all these things. ZK doesn't stop you needing these things, which means you're going to have to find some way of having probably no more than a third participants being bad. Probably you're going to have to go back to staking, like Ethereum L1 does, like Polkadot does, like most of the other chains do. Okay, let's look at this in an alternative way. Let's try and estimate the costs of a hypothetical ZK Jam guarantor node. So if you're not familiar with Jam, Jam basically has these participants called guarantors who are the entry sentinels into the Jam system. You send them transactions or work to be done. They kind of do the work, package it up, and send it off to the other validators who may or may not check they're working. They don't know. Well, what happens if we get rid of all that checking of the working and we reduce the staking requirements because we don't need to trust these guys to nearly the same degree, but we do require the guarantors to run basically a GPU cluster? Well, what would be the costs of that? Well, it turns out it's about $1.18, to the best of our estimations, in order to produce a ZK proof of at least doing SHA-1, 6 seconds worth, 12 megabytes I/O, basically this roughly the same thing that a Jam core can do in one slot. I say a Jam core. Jam has 341 of these things. But this is how much it costs. Probably, I mean, it's plus or minus. This stuff, it will depend a lot on exactly what the PVM execution is doing. We used SHA-1 as an example. If you use other examples, this cost will go up or down. But order of magnitude, it's probably about right. 118 for a core to produce 6 seconds. 6 seconds worth of correctness in one Jam core-ish. Now, if you extrapolate this over the year, then each core is going to cost about $9.5 million, assuming a 50% cost overhead for making it low latency, right? For distributing it out over a GPU cluster. Now, this 50% cost overhead, I don't know, maybe it's only 5%, maybe it's 200%. We don't know. So it's like picking the number out of the air for now. There is almost certainly going to be some cost overhead, and my expectation is it will be significant. Whether it's 50%, I don't know. But yeah, we're modeling, so at this point, yeah, $9.5 million, maybe a bit less, maybe a bit more, until we know precisely what this efficiency level is for proof distribution. It will be hard to say. How much does it cost at the moment, or given Polkadot's current staking system? Well, it turns out it costs a little under $1 million to provide the security that Elves, or at least 80% of the security that Elves uses for core. I say 80% because you're probably still going to need some sort of staking in order to look after those other things I mentioned, like running the main chain, settlement, finality, right? Storage. This is all important as well, but probably most important is correctness. So, assuming that 80% of the staking costs go to cover this, the cores, and assuming that we're running, 341 cores, and we're doing the current Polkadot staking tokenomics, then that's how much it costs. If we're running fewer cores, it will cost more, because it'll be the same staking tokenomics, just with a smaller division factor, right? We're sort of spreading the cost out amongst fewer cores. If we have all 341 executing, then it costs this much. So those two are basically the comparable things. So at the moment, we can basically say, roughly speaking, it costs about 10x to use ZK rather than Elves at present. Now, if we reduce security costs, which I think is presently attainable, that's what I would argue. We can talk about this later. I think we can get this 916 down to 270. And in fact, with integration into some of the new stuff that we're building, that I'm going to talk about later, we can probably get it down further to maybe 144, right? So this is sort of the comparison, maybe. This is a low number, though. So what do we come for? What's the conclusion? Basically, costs for ZK are coming down. I would still say it's about 10 to 100%, 10 to 100x higher than for elves. And this is, there's uncertain costs for the missing settlement, storage, and finality, which Jam provides, or which elves can sort of piggyback on. It turns out also that there is a mechanism such that elves can scale superlinearly, basically connecting multiple jams together and having them use the same validator set. ZK can't do this. ZK is very much linear. If you want to generate correctness for another core, you just have to pay this price again, right? It's not, you don't get to sort of combine it. There's some interesting points to this argument, and it will depend strategically. It's going to depend on a lot of things. So, how do we manage? What's the sensible strategy? What do I think is a sensible strategy? When will ZK Jam become sensible to pursue? I would say, firstly, proof costs need to reduce by 1 or 2 more orders of magnitude. Looking at previous history, this could take anywhere between 18 months and 5 years. I would say there needs to be open source tooling for efficient distribution of proof generation over a GPU cluster. There isn't at the moment, as far as I know. At least if there is, it's not the best, it's not the fastest that we found, and therefore these numbers wouldn't apply to it. Cores need to not clear at a price point. If they all clear at the price point that makes elves sensible, then it kind of also doesn't matter. And there needs to be a clear market differentiation between perfect security, which ZK provides, or at least in principle some ZK mechanisms, and bounded security, economically bounded security, which is what elves provides. It's not clear that the market cares which of these security mechanisms is used. There also need to be we need to be able to do the rest of what elves is or what Jam is doing without incurring the same staking costs, right? So basically secure storage, settlement, finality, these need non-stake-based protocols. If we have to stake again, and at least if the stake has to be similarly high, then we're not going to gain anything. We're just going to be paying extra for ZK. So proposing a ZK strategy, well, firstly, there is probably low-hanging fruit in terms of developing a ZK Jam service framework using the existing Jam crypto-economic elves-based mechanism. The nice thing about Jam is that in a Jam core, we do have all of this I/O, 12 megabytes, and a lot of CPU compute. A lot of this PVM is very fast, which means we can do a lot of ZK verification in a Jam core. And we don't need to do this costly and somewhat difficult sort of... So when you're doing ZK proofs, you basically do them in a bunch of stages, and the final stage is usually a proof compression, which makes the proof small and easy to verify. We don't necessarily need that because we have such grunt inside of a Jam core. We would focus on storage proofs since essentially cores, we have a lot of CPU, a lot of compute. We don't have so much I/O. Storage proofs can help mitigate that deficit. Essentially, it will allow us to do a lot of transactions quickly. The verification of signatures, all this sort of stuff is easy, but being certain that the transactions are drawing upon correct data is the hard thing. Midterm, it seems reasonable that we should use this. I mean, we already have this sort of Kusama sort of vision for supporting and building a sort of ZK network. Well, it seems well placed to use this budget to collaborate with other teams attempting to achieve basically well-optimized distributable proof generation tooling. If no teams exist, then starting a project. If teams do exist or want to pivot what they're doing towards this, collaborating and supporting those that are already doing the necessary work or necessary work. There should be it makes sense to focus particularly on PVM execution proofs, since this is what will be needed for a sort of ZK Jam to be compatible with regular Jam. And and obviously distributed proof generation. But we want to keep it modular and open so that we can sort of try and keep up with the state of the art. It's only by keeping up with the state of the art that we can reasonably hope to get these extra orders of magnitude that we need to make it commercially viable. Now, far term, we essentially need an alternative to full alternative to staking. Like if we're going to make ZK a thing, we also need to get rid of all of the staking stuff because this is what costs. So how do we get rid of staking and switch to a sort of ZK only jam? Well, firstly, there's only point in doing this once ZK drops in price sufficiently, right? And once we're fairly sure that we don't have an economically viable proposition for core utilization. This isn't clear yet. So this is only a sensible thing to do if this is the case. Then we could develop Jam into a multimodal security model with essentially having a sort of good security or like bounded security at very minimal marginal cost, and then also sort of perfect security or unbounded security at a substantial but linear cost, right? That would be utilizing ZK. Now, the interesting thing is that we would somehow have to do finality and storage in some way that didn't use staking. And this is the interesting thing. Now, how could we possibly do it if it doesn't use staking? One possibility is to use proof of personhood. And combining proof of personhood into core protocol could give major efficiency gains, major capital gains, capital efficiency. For this, you need strong, and I mean really, really strong anti-sybil mechanisms. I've only seen one that comes close. Most of them are nowhere near strong enough because they appeal to authority, or they involve a single organization that sort of collects people's data and decides who is a person and not. All right. I'm going to talk about this more in a second. For now, let's move back to staking costs. So, broadly calling this section fiscal discipline. Here's the headline figure, 500 million. It costs about this. This is about the annual spend for Polkadot at the moment on security. So Polkadot is basically paying this out to secure itself. It's quite a lot. Now, this is unmatched by income. Income is insignificant compared to this. Income basically being core time sales revenue. Now, if this all just stays in sort of dot, it doesn't really matter, right? But we do know some of it is going out because we know that some stakers, quite possibly many stakers, are in high tax jurisdictions. How many people stake here? Almost everyone. Now, how many people stake here and pay tax on their staking rewards? Almost everyone. How many people pay more than 10% tax on their staking rewards? Almost everyone. How many people pay more than 20% tax on their staking rewards? Okay, still quite a few. How many people pay more than 35% tax on their staking rewards? Okay, one or two, right? So it's somewhere between 20 and 30%. So, of the people here. Now, if you're a miner, right, mining is such a centralized affair, you can probably use the regular workarounds for tax avoidance, right? You put your mining rig in an offshore company, or you pay off an official, or whatever it is, right? But basically, mining is a lot easier to tax optimize than staking, because staking generally sends the existing sort of rewards into the hands of just sort of fairly regular people who live in fairly regular places that would quite like a slice of that. And especially as the world sort of looks increasingly, or the world's governments' books look increasingly decrepit, governments are starting to think, tax, that might be a good idea. Who can we tax that won't mind too much, or that is getting free money anyway? Staking is a really obvious target. And how many of you would, just out of interest, the ones that are paying any tax at all, how many of you would move to a low tax jurisdiction specifically to avoid paying that staking tax? How many of you are willing or already planning to up sticks and move? One. Right. So obviously not such a substantial... people clearly don't have a substantial commitment to keeping their chosen staking currency inside of that system. This is a problem. This is an economic problem for staking. Now, there's no great reason. I mean, I can't say for certain that all of the staking rewards get liquidated immediately, but we know quite a substantial portion of the rewards get liquidated immediately because of tax concerns. And to be honest, I don't see much reason to believe that the rest of the rewards are not going to get liquidated at the same time. It's only a theory, but I don't see any great reason. Ask me about it in the panel at the end if you want. So, how do we manage a long-term major structural deficit? Because it seems to me it's not generally acceptable. Well, you do what you can. You offset and you reduce. So firstly, you offset by attempting to bring in more revenue. So the way that we do this as a sort of commercial enterprise is, of course, we make what it is that we are supplying better, right? More valuable. So we improve the value of core time, because that's what we're effectively selling here. That's what Polkadot is using this security for, right? It's paying out $500 million a year in order to generate security, generate secure core time. So improve its value seems like a sensible thing to be doing. And this is already underway and has been underway for quite a long time, but elastic scaling, Polkadot Hub, Jam, right, is there essentially to take this secure core time and make it more useful, more valuable. Also, improving access to core time is very important, right? So SDK and documentations, Polkadot deployment portal, very nice piece of kit there. Ethereum compatibility, bridges, and I'm not naming everything. The list goes on. So apologies to those whose initiatives I haven't mentioned here. But nonetheless, this is part of offsetting, right? So attempting to make more valuable that which we are selling. However, I think there is also a perfectly reasonable argument to try to reduce costs. This is my proposal. I mean, not really mine. I don't really claim ownership, but I'm willing to back it. To get costs down from $500 million to little under 100 mil. Firstly, remove nominator slashing, right? You remove nominator slashing, then nomination essentially becomes risk-free, which means you can pay less for it. Introduce higher bars to validate in order to try and offset against that. Self-staking could be anonymous. Shout to Jeff for some of these points. Then, validators get a fixed fiat reward, right? Let's not kid ourselves. Validators have fixed costs. They need to pay for their own food, lodging, they need to pay for their own hardware. These are all fixed costs. And while we're at it, pay them in fiat. They're going to liquidate anyway for this stuff. Next, fixed reward for stakers. We decide what the reward is, we fix it, we decide we can sort of decide this based on sensible returns for a given opportunity cost. Example, if we say full self-stake costs $1 million, or is $1 million, and we say, right, 3% is the risk-free reward for that $1 million, then we end up with 30K a year. Easy. That should be the fixed, sorry, 30K a year? 300K a year. No, 30K a year. And that should be the fixed reward. OpenGov could set all of this stuff, right? This is fine-tuning. It could even be a panel of economists or something. But the point is that this stuff needs substantial insight, and I suspect substantial change. Commit to a long-term responsibility, like fiscal responsibility via a fixed issuance curve. Pretty fucking controversial, but I think it's sensible. Max issuance, let's pick something easy for people to understand, easy for people to remember, rational, reasonable, I don't know. Pi billion seems a nice, elegant figure. Now, sensible to have some sort of decay curve. It could be something as brutal as the halving curve. I think stepped is sensible. We have no great reason to not want to step it, to want to avoid stepping. It seems to be a good signaling system, at least in Bitcoin. So I would be down for taking that risk. Biannual might be sensible as well, over, for example, every 12 months. Yes. Now, just because there is a fixed issuance curve does not mean there needs to be fixed interest payments. Now, Bitcoin sort of equates the two, right? It says we're going to have a halvening, and that's going to be the block reward specifically at halvens. If you make a block roughly every 10 minutes, then you're going to get this amount at roughly every 10 minutes. I don't see any great need for this. We have governance, and we have an ability to, tweak things as needed. I think having a curve is sensible because that's a commitment. But decoupling these two can also be a very useful thing to do. There need be no great expectation that the interest the interest payable in order to get some certain security level should be exactly the same as what your issuance curve happens to be at that time, right? They're two different things. The amount that people are willing to sort of stake, the amount of security that they decide you need at any particular time, doesn't seem to be particularly connected to a dumb issuance curve. So it makes sense, in my mind at least, that we decouple these two things, and we have some sort of governance, maybe a board of economists, maybe just the straight fellowship, maybe the OpenGov, maybe just the referendums, but basically, maybe even some sort of algorithm, but basically we have a dynamic means of adjusting the effectively payable interest or the rate that we pay validators from a pot that is filled from issuance. Not necessarily the treasury pot. Think of it as unspent inflation. Now, in principle, if sales go up, or issuance just happens to be higher than what we need for security costs, then this pot gets fuller. And if sales are too low, if issuance isn't enough to cover security costs, the pot goes down. And then it gives governance time to reevaluate if its security expectations are perhaps too high. Or maybe too low in the case of the other direction. Midterm, I think there is a lot to be gained from creating a native stablecoin on Polkadot. Primarily for outgoing payments. Incoming payments, so basically purchasing core time, makes sense to keep that in DOT. But outgoing payments, especially if we know that we are paying effectively market salary for a commodity service where the amounts are going to be basically spent immediately in the real world on food, hardware costs, accommodation, or whatever else, it makes sense to for the system itself, for effectively Polkadot governance, to control when and how those things or those funds get converted into stable. And to the extent that we can create a stable coin, that means we can pay in fiat, but not have quite the same cost to the DOT ecosystem, then it seems to make sense. Now, security costs can be reduced further by using proof of personhood or anti-sybil mechanisms. And as I mentioned last year, this is a project that has been ongoing now for 3 years. Came up with it in summer 22. And it's taking a long time to bring to fruition. And it's not for want of effort, I can tell you. But this thing needs to be perfect. Now, a strong anti-sybil scheme can, I believe, make major contributions into security, and reduce overall costs of the core protocol. How would we do it? Well, this is still a sort of, this is still almost, it's just out of ideation, right? This is only just sort of putting pen to paper. But in essence, it works like this. The moment we have nominators, and through nomination, which is essentially a form of staking that you take a risk for, risk capital, you vote for validators who actually run the machinery. Well, we keep the validators and we pay them the amount to keep their hardware running and pay their bills and all the rest of it. But instead of nominators, we instead just have voters. We have regular people, right? We increase the weight of voters who back good validators. If you back a bad validator, then we reduce your weight, maybe slash your weight totally, and ban you for a bit, maybe a long bit. Obviously, if you are a bad validator, you get banned forever or whatever. We limit how many votes validators can accept. So there is a clear requirement, basically, for people to spread their votes over multiple validators, or vote for multiple validators, or not just vote for the most popular validators. The hard bit, of course, is matchmaking. How do good validators get discovered? By basically just people. This needs, I've got some ideas, but this is essentially UI integrations. Right? And this is something that, again, is being worked on behind the scenes, and I'm not yet ready to share those details. Validators would require proof of personhood, so they can be banned. Stake, so there is at least a baseline level of trust that they're going to be legit. And votes. If we do this, we can potentially and dramatically reduce the amount of outgoings via staking costs, probably about halve them. What else can we do? Well, we can introduce core disabling. One of the ways that Elves and Jam and Polkadot sort of work well is that they can take a single validator set and distribute the security they generate over a number of different sort of parallelized workloads. Essentially, they can multiply out their security. Unfortunately, that multiplying out, that sort of baseline security costs a lot, right? And if you don't have lots of users for it, then you end up paying a lot of money for like not all that much value. If we can disable how much effectively work we're doing, we can reduce the number of validators and pay out less. And that's basically what core disabling does. It doesn't really work like, it's not going to be in Jam v1, but it might be in a later upgrade to Jam, Jam v1.1 or whatever. And this allows us to be to keep costs minimal, while still providing the level of security that we would expect. All right, good. That's the first half of the talk. The second half of the talk is in some of these other directions that we are, and particularly me, but to some extent us all are looking into in the parity and Web3 world. First one is privacy protection. It's a bit of a touchy topic, this, particularly with all of the, tornado cash stuff. But the reality is that we do have, most people, probably most people here, have rights to privacy, either conventional rights or actually enshrined in some sort of constitution. And these rights are oftentimes disregarded by the powers that be, particularly banks. Now, of course, it's not up to the technologists to be forcing certain privacy affordances on people. Technologists are only here to enable individuals to use their rights, to exercise their rights. But it seems to me there is a distinct lack of effective technology for the exercising of certain rights. And that's something that I think needs to be fixed. So one of the things that we are looking into is creating tooling specifically designed to help exercise personal privacy, and doing so in a way that is legally safe for those that are providing this technology, but also those, to some extent, that are using it. And there are fairly clear published guidelines on the degree to which, for at least a fairly large segment of the world, privacy goes in the financial world. Now, this technology is actually already being used, or one half of it, in our individuality proof of personhood system in order to protect the identity of the individuals when they get given some reward within the individuality system. Now, if we look at the FATF guidelines, if you're not familiar with this, it's a sort of non-governmental, super governmental, you might say. It's kind of more powerful than most governments. Task force, basically committee, that kind of decide on the rules that banks need to, banks and other financial institutions need to obey. And if you look at one of the more recent FATF documents, their rules that they suggest that a lot of governments buy into are $1,000 per transaction is worthy of privacy. Anything more than that, KYC. And $10,000 per person per day is worthy of privacy. Anything more than that, KYC. All right. And to be honest, this kind of checks out because, at least in my interactions with banks, there are generally similar limits when I try and do anything beyond this. Like cash points, I can usually take out about $1,000, and anything more than that becomes a bit of an issue. And I have to go into the branch, and then at 10 grand, anything more than that, and I have to fill out forms. So it's sort of like, kind of makes some sense. And having chatted to some people that run apps that, for example, work for sort of voucher systems, they also have a similar, their lawyers tell them something similar. It's like, these are broadly accepted limits, and I think it makes some sense to try to create privacy primitives, financial privacy primitives, that easily provide users to have privacy up to these limits. Beyond that, and it might be a bit questionable. Okay, moving on. Individuality. Resisting sybil. This is a hard problem. Hard problem. Very hard problem. Resisting sybil in a Web3 world. How do we do this? So this is a project I've been working on for a while. I don't want to go too deeply into it because time is running out. But basically, proof of personhood, I believe, if it's successful, if it's ubiquitous, it can be a silver bullet. It can solve a lot of problems that we've been banging our heads against for 11 years, I've been at least banging my head against for 11 years. Now, it needs to be in line with Web3 ideals, anything else, and we're basically just going back to Web2, and this is no good. So, no confessional, which basically means you don't have to give away your privacy, right, your identity, to some institution, organization, Sam Altman, whatever, right? No confessional, no keymaster, no institution, organization, or random despot has the keys that can say you are an individual, you are not an individual, right? To have anyone or anything that has those keys is problematic. And this basically wipes out all of those schemes that use government IDs, that use GitHub commits, that, all of this stuff. No, they rely on a keymaster, or they rely on confessional, or they rely on both. And there needs to be privacy, hard privacy. As soon as we're working with individuality, then there's just so many potential avenues of misuse. For me to use this, would need to know that the maths clearly states my privacy is protected. This is what needs to be built. This is what needs to exist. And if it does exist, and if it gets used, that's another hard thing, then it can solve a lot of problems, I believe. What sort of problems? Well, basically, it can dramatically increase participation in Web3 systems, but also reduce the capital needs, capital costs. And I don't think this is lost on anyone. There have been plenty of attempts at doing proof-of-personhood systems, individuality. You only need to look at the projects, WorldCoin, various projects in the Ethereum ecosystem, Estonian digital ID even, right? This is an ongoing, there is ongoing attempts to solve this with various trade-offs. Well, what if there are no trade-offs? What if we actually want to do it properly, like once and for all? Can it be done? And if it's done, what would you use it for? Well, it's a game changer for things like staking, for stablecoins, for marketing, oracles, governance, and probably every aspect of blockchain. This can significantly improve or make more efficient, optimize, reduce costs, and so forth. These are some random screenshots from what we've been working on for the past 3 years, and it's coming soon. Launching towards the end of the year with 2 digital individuality mechanisms. One of them is proof of ink that I was discussing a year ago. I think I discussed it at Polkadot Decoded, where basically you get a unique tattoo in a particular place. And because it's unique, the chain basically tells you or gives you the option of what you get. Then you can claim your individuality. And because it's in a unique place, you can't get more than one of them, right? DIM 2 requires a bit less commitment. This is proof of video interaction. Yeah? More details to be coming in the near future. Treasury proposal is also incoming. This work will only be as valuable as the amount of people that we can draw in. And I think it's a kind of snowballing thing. I think if you can get sort of enough people through the door, it will sort of snowball up. But you need to get enough people through the door. Now, we're doing everything we can to make this as fun and cool and interesting and I don't know, something that you just want to do anyway, regardless of any of this individuality stuff, any of these benefits. But, in order to make it fun, it takes time. It takes a lot of iteration, and that's why it's taking a bit longer than I had originally expected. But when it's baked, it's going to be cool, I think. And that will be at least something to look forward to. Web3 Oracle. Now, this is something that, again, I feel isn't, it's been attempted a few times. None of the attempts that I've seen have really made me feel this is a sort of good combination of cost and generality and likely correctness. Now, it turns out that we need an oracle for that first digital individuality mechanism. decentralized. I think maybe it's decentralized individuality mechanism. But the actual Oracle mechanism is general enough that we could actually utilize it also for basically removing this kind of Polkadot registrar service that like checks out your identity. It's actually just run by Web3 Foundation. Well, in one case, Web3 Foundation. In another case, I think Chevdor originally, like one community member originally ran the service. Well, you know, this isn't really in line with Web3 at all. So let's try and move that into a Web3 mechanism, and this is how we do it. It's needed for DIM1 as well, for reasons that will become obvious when you start using this app. Moving on, Web3 outposts. Now, this is sort of a series of projects that have been on my sort of back burner for some time, and they're starting to come to fruition. And as they do, I'm kind of pivoting my focus increasingly towards them, with the idea of trying to bring Web3 into meat space. So really kind of community spaces, if you like. What are they specifically? Well, rules-based, collaborative, high-tech work-life space. Community spaces, but rules-based community spaces. Web3 is a rules-based concept, right? It's like key parts of it are rules-based. It's about fulfilling expectations, the expectations of the users primarily. And in order to fulfill expectations in spaces, well, you need to have clear rules for the spaces, rules of interaction, manners, politeness, language expectations, and so forth. And different spaces, of course, may have different rules associated with them. And you do, of course, need some means of enforcing the rules, right? Security mechanisms. What they intended for? Well, a bunch of stuff, outreach, community, experimentation in particular, integration between various different aspects of life, at least bits of life that I think are interesting. Web3 blockchain, meat space enterprise, like selling stuff, you know, providing services, drinks, food, whatever, art, culture, and adjacent technologies that are adjacent to Web3, but not Web3 itself. Some things are going to be much more focused on some, I should say, outposts, will be much more focused on some of these things than others. But that's the sort of broad area. Why are they different to any other community space? Well, because they're blockchain-based, right? Want to create these rules-based spaces on the back of actual technology, not just a community area where people who like the technology kind of go. Now, some of these community sort of areas have maybe got a burner wallet thing where you can spend stuff. I've seen this before. You maybe have sort of tokens that you can spend. But we want to take it much, much further. We want to like have, for example, rooms and a booking system and that tie into collectives and groups that exist on chain, such that someone, without giving away their identity even, can become a part of become a part of a collective, can book a room in a Web3 outpost, can make their way all the way through security gates into the place, all the way to their room, just by using their phone, QR code, similar to how Polkadot Vault works. And this should all be done without there needing to be a single person who is administering it. It should all be autonomous. This is the kind of system that I think that interests me. This is the kind of space, physical space, that interests me to build. And the idea is that when these systems are created and in use, we can minimize costs, we can minimize overhead, we can minimize the trust needed to be placed. Like imagine a bar where you don't actually need to sort of trust that the bar steward is actually doing much other than serving particular drinks. You don't need to do stock control, you don't need to do, I don't know, whatever else. Security, I suppose. This is what I would quite like to focus on in the not too distant future. How do we manage it? Individuality, very important. We need to be able to ban people if they're bad. Space provision, on-chain groups. We already have started in this, of course, the fellowship Kusama Society being a couple of examples here. Old-fashioned crypto. Hardware, door locks, integrations, WhatsApp bots, and effective user interface. The last one is very important. Very, very important. So what we've got under development, the Emergent College is the biggest, and that is going to be the subject of a talk that is coming next. No, not quite next. Demo first, then that talk. Then there's also the Kusama Bar, or Club Kusama, which has been almost open for some years now. And I'm hoping that we will actually get it open in the not-too-distant future. And another bar in Malta. Now, last thing I want to talk about very briefly, stablecoin. I mentioned it earlier, something that I want to bring. What are we trying to achieve? Well, basically, a proper Web3 stablecoin. Now, there are a few out there, some more Web3 than others. The ones that are under major use are not Web3, just sort of bullshit Web3 shims for Web2 stuff. It's got to be decentralized, right? So no centralized issuer. It's got to be sound. It's got to be like actually economically sound, rational argument as to why it should retain its value. It's got to be capital efficient. A lot of the decentralized ones are not capital efficient at all. It's got to be inclusive. It's got to be scalable. And it's got to be universal. One of the more interesting, more recent ones is Circles, is pretty cool idea. Unfortunately, not universal, right? It's like it can depend on where you are in the graph, and this is an issue for what I want to achieve with this thing anyway. I'm not going to go into technical details. That will be a different talk later this year, but DOT will be used as in part as collateral. It would function as part of this. It would contribute to this project, and there will be a treasury proposal incoming for bootstrapping this. Good. Right. That's the initial talk. Now I would like to, if I can, move on to my demo. So I mentioned before we've got Jam. Now, can you actually see that? Not really, but we'll have to manage. I want to give you just a quick demo of Jam to show you the sorts of things that I am looking forward to devs playing with in the not-too-distant future. So Jam is attempting to do new things with old technology. The old technology in this case is the technology used for Polkadot, basically elves, blockchain, erasure coding, this sort of thing. Here, hold on a minute, let's restart that because I'm not sure it is running. Restart this. All right. So here is a monitor. This is monitoring the, this is basically, you can imagine this as a video screen connected virtually into a computer. The computer is running a piece of software called WS Demo. There it is. And that software is running on this Jam. This, so I'm running a Jam in the background, 6 nodes worth, 2 cores, right? So it's kind of a fairly basic CPU, but still decentralized. This is a table of processes or services that are running on that decentralized computer. You can see at the moment it's basically this yellow line is sort of zigzagging as the process switches between core 0 and core 1 on which it's executing. It doesn't care, it doesn't mind, it doesn't know, right? Services can use whatever core they want, just like processes on a regular computer. This green line is basically the results of what's happening on the core are being sort of folded in to the broad system. They need to be folded into the broad system in order for them to display on this monitor, this screen here. This monitor, this window, is provided separately to everything else by this thing here. This terminal is running it. There is another terminal which is basically ticking along this process. It's like sort of collating, if you like, for it, or sequencing, I don't know, whatever you want to call it, but basically keeping it going. And in essence, it's the paymaster. It's the one that's paying for the process to keep running. At the moment, it's not doing very much. Now, it is actually generating frames, as you can see here. It's this monitor is capable of representing console output, video output, and audio output. I don't have the time to build you like an audio thing, and if I did, it would only be like a pretty annoying tone, so I wouldn't worry too much. But you can see here it is occasionally yielded, like it only prints a message when it yields 100 frames to avoid it just going up all the time. Now, it can also accept input, right? And the input, annoyingly, doesn't go into the monitor because that's output only. It goes into the builder, which is this thing down here. I can type some input like hello, and it will basically send hello, a bit like in a transaction, into this software that is generating this screen. And eventually, it takes a little while. It's got like, I think, about 6 to 12 seconds of latency. It gives a message out, not supported. It doesn't know what to do with hello. Now, let's have a look at the code that is doing this. Here is the code. I'm going to make this a bit bigger because you probably can't see much of this. It's not a big program, and I could make it a lot smaller, but I wanted to limit the amount of typing I was going to do in this little demo. For a start, I can remove those lines. Right, what's going on then? Well, basically, we decide how wide we want our video window to be, how high palette. We're going to have a palette, 256 color palette. Pixels are obviously the width times the height, and the maximum frame length is basically a byte to say whether there's a palette at the beginning, the palette, and then the pixels. Easy. Video frame generator, we're just going to have our frame that we're going to generate, make a new one, that just generates a blank frame. Generate function is going to put some stuff in that frame. Let's see how this works. Well, firstly, we put the first byte is 1, just to say there's going to be a palette. There's always a palette. And we're going to reset our palette all to black, 0, 0, 0, red, green, blue. And then also in number 0, palette index 0, we're actually going to change that so that it is mostly red, a bit of green, no blue. And then palette index 1, we're going to make it mostly blue, a bit of green, and no red. Like that. That's where those two colors come from. That pattern comes from basically this bit of code, y over 16 plus x over 16. Mod 2, that gives us a checkerboard pattern. And it's flipping between 0 and 1, 0 being red-ish and 1 being bluish. Let's change this so that we are... let's use frame number. So instead of using the y coordinate, we're going to offset that by the frame number, which is being passed in here. And we're going to, while I'm explaining this code, just going to recompile that. Yeah, we use that to recompile, and then takes a little while. There we go. That's compiled it into w3sdemo.core-vm. Now, I'm going to upgrade this process, this service, to this new code using this little command line thing here. Jam-t, jam tool, VM, virtual machine, upgrade it please. That's the ID, this crazy 395D, that corresponds to this thing here at the top. And then what we want to upgrade it with, well, the new Web3 Summit demo code. I'll pop that in, and that's sent it off. And at some point in the not too distant future, probably the next block, this is going to have an extra bit of orange to denote that, there it is, to denote that it's got an upgrade thing coming in. And this will eventually, there's a slight bug in the builder, and it's going to stop building when it's upgraded. I have to restart it. It's not a big deal. But that's just the thing that is ticking it along, so it's not that important. So what's happening in main? Well, basically, we set up our video mode. Bam. We make a new generator. Easy enough. We set our frame number to 0, because it starts at 0. We process any messages, which at the moment does nothing. We generate a frame which calls that code there, makes our checkerboard pattern. We yield it out, so it's going to put it on the monitor, and we tick it along and print yielded frame if we're on a multiple of 100. And as I mentioned, process messages doesn't do anything at the moment. It just tries to read in a message and says, well, this message is not supported because it doesn't know what messages are yet. This is where if we were doing a transaction processing thing, we put our transaction decoding logic. So, oh, hold on, did I not, what did I just not save? I did not save that, right? Then in that case, I need to do this again. And upgrade again. Oh, no, it doesn't like this. What have I done wrong? No implementation. Ah, yes, okay. So we need to, this is just a minor Rust thing. Just change that to a U size. Now, what we should expect is basically that the checkerboard pattern is going to scroll as the frames move along. The checkerboard pattern will sort of move up the screen because we're offsetting the Y coordinate by the frame number. And while that's upgrading. Good. All right, there we go. So that's upgraded, and this will, as I said, the builder takes a little while to carry the upgrade through, and when it does, it will probably tell us by stopping. Let's do something else as well. Let's make a message. Let's make it understand something from the outside world. So what we can do is maybe, let's make it understand invert. And we'll make invert the color scheme. What's this? Found static string. Oh, okay. And in order to do that, what we need to do is pass in our frame generator. So we will do that by passing in &gen. And gen is a, oh no, hold on, &mute gen. And gen is a mutable reference to our frame generator. And then we will, if we get an invert, oops, we will first print inverting, and then we will gen.invert equals not gen.invert. Now we need to add invert to our generator, so bool, and then we need to do something if this is true, such as if invert self.invert, then let's basically just change the colors a bit. I don't know. I guess we'll just do it like this. And 255. Apologies for doing this in a very inefficient way, but you get the impression. Good. Now, that, as I said, is probably not... yeah, there we go. So that stopped a while back, so we're going to restart it, so it's going to start generating frames again. Now, when it generates frames, we should expect to see the new code executing in this process. And so there we go. So that's scrolling. Next, let's try and compile our new code and see if we can send it a message. See if we can send it the invert message. Not yet. Self. We're missing invert. That makes sense. We're missing it here. Invert is false. And try again. Right. Good. And then we upgrade that again. Sorry you can't see the text. There's not that much to read. Mostly just messages. The important stuff is here, which I will make bigger, and the output there. Right, now, as I said before, the builder gets sort of confused on an upgrade at the moment. There's no great reason why it should get confused. It's just a minor bug, but it's not a bug that I could sort out before right now. So we're going to just restart it quickly. And now it's going to take the thing along with the new code, having reset the memory and all that sort of thing. And if it works, it should do basically the same thing, but if we type invert, oh, not in there, in here. Did I mess that up? No, okay. Then we should get a message in here that denotes that it's understood what we said, like basically says inverting or whatever that there we go, inverting, and not, there we go. All right, very good, very good. I'm going to leave it there for now, but you get the impression. There's a lot more that I could demo, in particular inter-service communication, so the ability for two services to basically send each other messages. A transaction processor, so the ability for a transaction basically in this process messages to sort of process an indefinite amount of transactions, look at signatures, all that sort of thing. Look at where the message came from. At the moment, we get a source, which is either, if no one has signed it, basically if it's coming in via a work package, it's this is none, whereas if it comes from another service, it's some. So it's got a lot of the stuff that we kind of really need to be able to build stuff, with the great thing being that this has just got a single entry point, main, with a big loop, right? There's no like necessity to think about things anymore in terms of you know, trying to have a clear memory when a new transaction comes in. You can kind of be lazy. You can kind of use regular programming techniques. Now, of course, when it comes to optimization, there may be some things that you do want to do, but the main thing is to make this as accessible as possible and to provide a means by which we can use some of this crazy amounts of compute and storage that we are providing, right? We want to make it, we want to unlock new applications. And we're not going to unlock new applications, I suspect, using old paradigms. Ken and I will chat a bit and take a few questions. Ken Kapler here is co-founder of Parity, back from the days when Parity was actually F-Core, long ago. And
very long ago.
And is currently serving as an advisor to the Web3 Foundation Council.
Thanks. I thought we could have a quick chat about some of the proposals around the staking rewards and then take a few questions from the audience. I think one of the things that I wanted to kind of touch on again, and I know you did your audience participation bit regarding taxes, how much do you feel the government slice of your security rewards is kind of motivating you to try and change these rewards?
It's been a concern for many years, and I've spent substantial time trying to imagine a staking system that didn't involve balances going up, since this seems to be the sticking point with financial reporting. And I think
so potentially everybody else's dots disappearing would be one way we could.
I mean, yeah, demurrage is the obvious answer to this, where rather than rewarding those that are helping secure the system, you sort of penalize those that are not helping. It wouldn't map especially well onto the Polkadot staking system as it stands. It would need quite a substantial redesign, mostly because we reward different people differently according to various factors, and it would be difficult to translate that into demurrage. Like, you'd have to kind of demurrage all of, like, basically everybody, not just those who are not contributing at all. And then beyond that, there are a few other ideas that I had, like maybe having different, like having vast amounts of tokens and really very fast, easy to set up decentralized exchanges, such that essentially as a validator, you basically just make your own token every day, and Polkadot eventually sort of buys it off you. Which could, in some jurisdictions, help. But basically, it's a hard problem. Like, demurrage is non-trivial to introduce, and it's not clear that there is a much better way of handling this.
Well, I think it would seem that Bitcoin miners have hardware capital costs, which they could write off against their taxes. Whereas stakers, they have, well, capital costs in keeping their dots locked up, but that's not something they can claim as being a cost to them. So I think you kind of hit the nail on the head with the fact that the validators have these fixed costs. They're effectively making a margin on renting hardware and then, charging, taking a portion of the rewards. Do you think that changing to fiat for their rewards is going to, some way stop us seeing so much DOT going into government coffers?
No, but it cleans things up a little bit. Firstly, it reduces the amount that it reduces our guesswork. And secondly, it allows us to choose which stablecoin or the means and timing by which it goes out. If we know or strongly suspect it's leaving the economy anyway, then better that it sort of stays in the economy in part as a local stablecoin than that it leaves entirely as a bank balance.
Because we kind of generally know that most stablecoins are never, things like Tether are rarely kind of sent back to the creator for cash. They do end up getting recirculated. There was a lot of proposals there. Do you consider them to be something that each individual one would need to be considered on its own merits, or do you feel that there's, this needs to be a package of reforms?
I do think reform is necessary. I think, and I think to taken together, it's a sensible way forward. I wouldn't have suggested them all if I didn't think that they could actually be taken as a package. That said, each, I would say, stands on its own. I don't think that any of them are particularly dependent on any others. I think introducing a stable coin that is, has at least to some degree is collateralized by DOT is sensible. I think we can do a lot better than an over-collateralized stable similar to DAI. I think we can do a lot better than Tether and Circle. So I think that we are overpaying for security. I think that we are overstating how much security is needed at present. We should obviously retain the ability to ramp security up if it is needed. But as long as it's not being used, as long as it's not needed, it doesn't seem sensible to be quite so profligate in our security payments.
Okay. Do we have any questions from the audience? We can't see anything here, so.
You want to shout? Try shouting. So how do I see it combining with Jam? So, Jam is a protocol. And Jam does change some stuff from the original Polkadot protocol, right? Polkadot was very much based around this concept of parachains. If you go back to the original Polkadot paper that I wrote back in, 2016, it talks about like a heterogeneous, scalable multi-chain, right? And the idea that each of these chains kind of have different logic, but they're all secured by this same umbrella chain. It's always been focused around chains, and Jam lifts some of those restrictions or constraints that we placed on the protocol in order to facilitate the security apparatus being used for securing blockchains. And the two are very compatible, right? Jam is a protocol, Polkadot is a network / token economy that needs a protocol. Like, the two are very compatible. But at the end of the day, the two should be best treated as different things. This will allow us to get the best out of both of them. And this is why I present a different governance. Now, to the extent that Polkadot is of the opinion that Jam is a useful protocol for it to be based on, then it makes sense for it to use Jam and sort of support the Jam efforts. And similarly, to the extent that Jam wants to be relevant to Polkadot, it should listen to what Polkadot wants. But bundling everything up into sort of the same, I don't know, brand, team, community, direction doesn't actually solve anything, because they are different things. A token economy is not a protocol. Yeah? And pretending that it is doesn't help you, right? Other than, for the first period of time where you can try and forget. But the reality is that they are different. And there can be great gains, I believe, by treating them as different things. To the extent that Jam can become something beyond that which merely Polkadot uses, can benefit Polkadot very greatly. I would argue that Ethereum, because the EVM became such a sort of universal standard, being chipped away at, admittedly, but still de facto the most prevalent consensus architecture, allowed Ethereum, the network, to piggyback on that success, right? To wield it, to leverage it. And to the extent that we can make PVM, and in turn Jam, a global standard for consensus, this will facilitate Polkadot's ability to leverage its underlying technology for greater gain. Any other questions? Very little. Actually, very little. I'm a very these days anyway. I'm a very sound sleeper. Honestly, this stuff doesn't keep me up. What kept me up was family matters, which are increasingly resolving themselves in very happy directions. And I don't think this stuff should. Like, when you're contributing to the world, it's like if you shouldn't be up at night because you feel that you're contributing less than before, or that you might not be able to contribute as much in the future. This isn't a sensible reason to keep yourself up in the night. So no, this is very little is keeping me up these days. Your your interest is touching. Thank you.
I'm sleeping well as well. Thank you.
Any other questions? Sure. That seems about right. So I think if we have a clear eventual total issuance, or what do we call it, asymptotic issuance, then it doesn't really need to be a wish for change because it's implied by the protocol itself, which already went through governance. So the question is, will we get, I think at the moment we don't have an asymptotic issuance. We have an asymptotic issuance rate of 0. But the actual issuance is fixed, as far as I remember. And we should, if we are up for asymptotic issuance, total issuance, then that needs to go through governance, either as a wish for change or preferably as like proper code. Once it's in there, I think it's perfectly reasonable for Jam to just duplicate it. Mm. Mm-hmm. Yeah, so I think the point of this is really to try to provide our economists, maybe armchair economists, with some knobs that they can turn. It's a hard thing to limit issuance. Like, this is not to be taken lightly. I think it is, on balance, a reasonable thing to do at this stage. I think the degree of commitment that Polkadot shows to fiscal discipline outweighs the limit of flexibility it will face in the future at this stage. It's a very tough one. I very much dislike limiting flexibility, but at the end of the day, we're not going to be. There is no what's it called? We're not in a position where we have arbitrary options to choose from. Yeah. But just because we limit issuance doesn't mean we have to blow it all in the first 2, 4, 6 years. Yeah? We should limit issuance, but we should also try to understand what security we really need. And my feeling is that the security that we need and the cost of that security will be less initially than the issuance. And as such, it makes sense not to blow it all and overpay for security, but rather keep it aside for a rainy day. And that's what this pot would be for. A rainy day of security, or a rainy day of transaction fees, core time sales, whatever. No, the issue is that it's all very well if your asymptotic cost is 0, but if your actual usage is low, you won't get to that asymptotic cost anywhere near. And that's where we're at the moment. In principle, we have the know-how and technology. The software isn't yet written, but we know what needs to be written in order to get to an asymptotic cost of 0. But it requires there to be, 1 million cores, all under utilization. Yeah? That will take the actual cost per core down to something effectively insignificant, or where a single user's transaction becomes close enough to 0 that we can round it down, right? But we're not at the stage of having 1 million cores under constant usage by users, right? We're at the stage of having maybe 40 cores under partial usage. Some of the cores are doing close to 100%, but not many, right? A small number, a very small number. And this is not specific. This is not like an issue with Polkadot per se. This is an issue with Web3 in general. We just haven't got to the stage of servicing that many people for that many things. And as I said before with the demo of Jam, one of the reasons that this like generating graphics and audio and all this stuff seems frivolous for block space. But the point is that we have a lot of block space, and we want to find usages for it. And combining media with transactions and economics and money seems like a pretty sensible thing of like finding, it's fertile ground, It's not in and of itself an obvious use case, but it's an area of use cases that has not yet been explored. And this is what I believe we need to do. We need to explore new use cases, new areas of use cases, and we need to explore new ways of bringing in a lot more people. And that's where the Individuality program comes from, right? This is essentially a mechanism to bring in as many people as possible. How? Quite honestly, airdrops. But not crappy airdrops that basically just make existing large wallets a bit richer. Not crappy airdrops that, and sorry for saying this, but go to the same, 10 or 20,000 people. But airdrops that target like the world, that target non-crypto users, that target people who can use an Android phone and download an app that their mate sends them a link to, right? That's the kind of people that we want to be targeting. And it's once, of course, getting their attention is one thing. Getting them to become users of applications that exist on chain or powered by Jam or whatever is a different thing. But you need the first, I believe, to facilitate the second. So, no, it's not divergent from the original concept of close to zero transaction fees. Rather, it is dealing in a world where we are not at that scale yet. And I think it makes sense to assume this is going to be a marathon rather than a sprint. So let's do it right. Let's feel comfortable, and let's work from there. This is my feeling at the moment. And I would point out as well that we have the resources to stay for the marathon. Yeah. In due time. Any other questions? No? All right. Oh, one? You want to shout? I said. So, I mean, okay, look. The way I look upon it is this. The systems that we've built assume a threshold of honest behavior. And broadly speaking, if you have enough people and you ask them about anything, you're going to get an answer that isn't really aligned because there's enough. We assume that there's enough different people, other than physical reality. If you ask them about how long is how far does light travel in a millionth of a second, you're going to get, one would hope, a sensible answer from a consensus answer. But when we talk about when we talk about changing a system not to the benefit of everyone, then we shouldn't get an aligned answer. Now, if some, mad, malicious alien villain comes along, right, and pays enough people such that most people vote for this thing that is totally against their interest, then yeah, sure. But you need a mad, malicious alien villain for that. And, you know, and we assume for now that, you know, if people are staked in the system, they are going to, you know, not be under the mad, malicious alien villain thumb, right? Well, it seems to me that, firstly, staking is not the silver bullet, right? Because most stakers, most nominators anyway, don't seem to care that much about who they nominate. And we're kind of increasingly flirting with mechanisms to increase nominations and effectively reduce the consideration needed for those nominations, right? In the early days of Polkadot, you actually needed to go out of your way to kind of research, like, you know, there were no obvious defaults. In later days, we have nomination pools where it's like, you know, you kind of don't have to think. And it seems to me that if we are accepting that nomination is not that silver bullet, or staking rather is not that silver bullet, there may be other ways of getting to this base threshold of a third honest, of less than a third dishonest participants. And a large non-aligned community of people that are paid probably a little bit, or even punished a little bit for not voting, and provided ample means of matchmaking, is a reasonable direction to go in. I mean, we'll see, but until we answer the question of cost, then the onus is on those that would keep the staking machinery to prove that nomination is substantially more secure than anti-sybil voting. Good. All right. I guess we're probably about time. I believe we still have a movie for those of you who are interested in seeing what I got up to in the first part of this year. Thank you for your attention, guys.
Thank you.
Enjoy the rest of the conference.